Now let's do few questions on log, and the question is log 7 root 7 under root 7 and under root 7, and these are the options. So the question is log 7 root 7 root 7 and then root 7. Suppose it is equals to x equals to log 7 take this 7 under the root and it will become 49. So root 49 into 7 root 7. Take this under this root, under the last root, so it will become log 7 log root. This will become 49 ka square and this will become 7 ka square. So in last root we'll have 7 square into 49 square into 7. 49 square we can write it as 7 square. 7 square ka square equals to 7 raised to the power 4, and this is 7 raised to the power square, so the power will be added, so it will become 7 raised to the power 6, and this is 1, so it will become 7 raised to the power 7. So we'll have log 7 7 raised to the power 7 root and one more root. So the first root we can write it as 7 raised to the power 7 by 2, and this root we can write it as 7 raised to the power 7 by 2 into 1 by 2, and this we can write it as if you want to remove the roots we can write it as 7 raised to the power 7 into 1 by 2 ka cube. Log 7 raised to the power 7 and 1 by 2 cube equals to 8. So we can write it as log 7 by 8 log 7. So this will become 1. Log 7 will become 1. So we are left with log 7 by 8, and log 7 by 8 we can write it as log 7 minus log 8. So the base is 7, so log base 7 result 7 equals to 1, and this will be let's change the base, log 2 8 and log 2 7. I've already told you this property when I was teaching logarithms, that we can change the base like this, so it will become 8 we can write it as 2 cube, 3 will come out and it will become log 2 which is 1, and log 2 7 which we can write it as log 7 2. So the answer should be 1 minus 3 log 7 2. Now let's just do a different question, and the question says the value of log 3 base 3 4 log 4 5 5 6 6 7 7 8 8 9 is these are the four options. So let's solve it. The question is log 3 4, log 4 5, log 5 6, log 6 7, log 7 8, and log 8 9. So using the base change formula, these last two term will become log 7 9. This we can write these last two terms as log 7 9, and this is we can write it as log 6 9, and we can write it as log 6 9, we can write it as log 5 9, we can write it as log 4 9, and we can 4 9, and we can write it as log 3 9. So if we simplify this, we'll get log 3 9, and 9 is nothing but 3 ka square, which will become 2 log 3 base 3. So log 3 base 3 is equals to 1, and the answer is 2. Thank you. Now let's just do a question, and the question says the number log base 27 is an integer, a rational number, or an irrational number, or prime number. So we have question 1, and we have to find if log 2 by 7 is an irrational number, rational number, an integer, or a prime number. So it is very clear, like if I raise 2 to the power, if I raise 2 to any power, it will not give us 7. So it cannot be an integer. If it cannot be an integer, it cannot be a prime number as well. So we are left with only two options, whether log 2 7 base 2 will be a rational number, or log 7 base 2 will be an irrational number. So let's assume that it's a rational number. So suppose I raise 2 to the power p by q. Suppose I raise 2 to the power p by q, I'll get 7. Suppose I raise 2 raised to the power p by q, I get 7. Now raise 2 to the power p by q to q. So we'll get 2 raised to the power p equals to 7q. So let's try to understand this. Let's multiply 7 into 7 into 7 into 7. We'll have 7 into 7, 49. 49 into 7 will give a number, and that number at one's place will have 3. So then again, if we multiply it by 7, we'll get a number, and the number at one's the one's place of that number will be 1. And if we again multiply it by 7, we get 7. So we'll have 9. If we multiply 7 by 7, we'll have 9. And if we multiply it by 7, we'll have 3. And if we multiply it by again 7, we'll have 7. And if 1, and if we again multiply it by 7, we'll get 7. So we cannot have any value of p by q will not have any value of p by q that satisfy this equation, so it can't be a rational number, and the only option we left with, it will be an irrational number. So yes, log 2 by 7, log base 2 7 is an irrational number. Let's do another question. And the good thing about this question is, like, it has multiple concepts in it. So the question is, if a comma b comma c are distinct positive numbers, a b c are positive numbers and they are different, they all are different, each different from 1, and they are not equals to 1, so such that log base b a c log base c a minus log base a and so on equals to 0, then abc equals to. So what is the question? Question is, log ba log ca minus log aa plus log ab log cb minus log bb equals to this, plus log ac log bc minus log cc equals to 0. So let's just change the base and take any random base, like we can take e, or we can take pi, or we can take any number. So let's just take pi. So we can write it as, or take e, because we are more familiar with Neperian log, so take e. So the first bracket we can write it as ln a upon ln b into ln a upon ln c minus log base a equals to 1 minus 1, and this will become ln a square upon ln b into ln c. Now multiply ln a, now multiply numerator by ln a and divide the numerator by ln a. So we'll have ln a cube and ln a b ln c into ln a. So same goes with this. From here we will have ln b cube upon ln a ln b and ln c minus 2. Now in third one we can have ln c cube upon ln abc ln a ln b ln c minus 1. So we'll have ln a whole cube ln a ln b ln c plus ln b whole cube ln a ln b ln c same ln c whole cube ln a ln b, and we'll have ln c minus 3. So as equals to 0, yes, the whole thing is equals to 0. Now take this LCM, lowest common multiple, and we'll have ln a ln b ln c, and in numerator we'll have ln a cube plus ln b cube plus ln c cube minus 3 ln a ln b into ln c. So, and the whole is equals to 0. So we cannot have ln a ln b ln c as 0 because the base is e and a b c are distinct positive real numbers and not equals to 1. So we cannot have ln a equals to 0, ln b equals to 0, or ln c equals to so the base cannot be, denominator cannot be equals to 0. So the only condition we'll have is we can have numerator equals to 0. Suppose take ln a equals to x, ln b equals to y, and ln c equals to z. So we can have x cube plus y cube plus z cube minus 3xyz equals to 0. So how there is a, so we'll have to prove it 0. So the one of the root of this equation is x plus y plus z equals to 0, and let me prove it. Suppose x plus y plus z equals to 0, and we can say x plus y equals to minus z, then take cube on both the sides, both the sides. So we can have x plus y, x cube y cube plus 3x y, x plus y, or from first x plus y is nothing but it is equals to minus z, and it is minus z equals to z cube. So we'll have x cube plus y cube minus 3xyz equals to z cube. So x plus y plus z is one of the root of the equation, and if we factorize it, if we divide this equation by x as x plus y plus z equals to 0 is one of the root of this equation, and if we divide it by x plus y plus z, it will be a multiple of x plus y plus z, because x plus y plus z equals to 0 is one of the root of this equation. So when we divide it, I'm not doing the whole I'm not going to divide it by x plus y plus z. I'm simply putting the result, and it will give us x plus y plus z. You can do it on your own, equals to x square plus y square plus z square minus xy minus yz and minus zx. If you see this part cannot be equals to 0, because if you multiply it by 2 and divide it by 2, so it will give us x plus y plus z, x minus y square plus y minus z square plus z minus x square upon 1 by 2. So it cannot be equals to 0. So the only option we are left with is this, x plus y plus z equals to 0, and x is ln a plus ln b plus ln c equals to 0, and we can write it as ln ABC equals to 0. So ABC e raised to the power 0 equals to 1. So ABC is equals to 1. Thank you.